multiplication and division. So I don't know if there is anything that is that you want to understand from there before we move on to another part. Like anything that has to
No,
do with fractions, everything is fine.
yeah, it's fine. Everything is
All
fine.
right.
We don't. It's fine.
It's okay. So we have the other part that is of the application of number basis, which is very, very important. So here we're just saving the basic part, introduction, then later on, we'll be having more questions from past exam papers. But as we are revising now, you can see that even some of the questions right now in paper one, we have those typical questions, so you can even revise from there.
Yeah.
All right, so I want us to check this part on number basis. All right, this is one of the most important parts in our syllabus, as we'll be talking of the change of bases from base of two, from any base. So we are saying that numbers can be expressed in any base. Let's say we are writing a number like 1, 1, 0, 1, like this in base of 2. So this is representing the base. So that's our base there. So we are saying numbers can be written in different bases: 2, 1, 3, base of 5, 1, 7, 7, base of 9. So there are so many ways, so many bases that we can actually use. So we are going to see that of all these bases that we have, there is a major base that we use, which is the base of 10. So the base of 10, we are referring this one as a major base to say that is our common base. If we are referring to numbers like what we do every day, we can just say 3 or 5 loaves or whatever. We just mention any number without writing the base or without even saying the base to say, can you bring me 3 base 10 loaves? If it is 3 loaves, we just say 3 loaves. But each and every number that we call every day, there is a base which is there, which is base of what? Which is base of 10. So, meaning to say, a number that is written as 3 base 10 can be just be written as a normal number as 3. So whenever you see that the base is not given, you must know that the base that is there is base of what? Is base of 10. All right,
10.
so exactly. So what I want us to do is to know the conversion part that is with, since we are saying base 10 is our common base. So we want to see the conversion that these bases do, base 2, base 5, base 9, any base. How can they be related to base 10? Or how can we convert from these bases to base of 10 or from base 10 to these bases? Because since it is a base, we can change to another base. All right, so the first part that we shall have is on conversion, which is converting from the major base, which is base of what? Which is base 10 or our common base. So we are going to convert. So this is converting from base 10 to any base. So we are converting from base 10 to any base that you can think about, which is base 3, base 5, whatever base. Okay, so what you're going to do is you divide throughout by the base. Divide throughout by the given base. If you are converting to base 5, you divide by that 5 throughout. So you divide throughout by the given base, noting all the remainders. Noting all the remainders. All right, so I shall explain this part later on. So you note all the remainders that you are given. All right, after that, take the final answer. Take the final answer from the bottom of remainders, for bottom of remainders, from the bottom of remainders upwards. Okay, so I want us to see something here. We are saying that, let's say there is a number that is given in base of which is in base of 10, like I was saying. You want to convert to what? To base 5. What you're going to do is that you divide by 5 throughout. You are dividing by 5 throughout. And you are writing, that is to note the remainders. But on your final answer now, you take these values from what? From the bottom of remainders upwards. Okay. Let's say we have got a number such as convert, let's say our first person, we are converting from base 10. Okay. So you can be asked to convert the following, convert the following to the given base. Okay, convert the following to the given base. Okay. The first part. Okay. Let's just can I just remove this part?
Okay.
Okay. Okay. Convert from base 10 to the given base. All right. So we have got in this case, let's say the first one can be 20. So if you like I was saying, if a number is written like that, you must know that it's in what? It's in base of what? It's in base of 10. So when you are just given 20 like this, you know that it's in base 10. So base 10, there's no need for them to write base 10. So we have got 20 to base 5. All right. So are you seeing the question there?
Yes.
Okay. So in order for you to convert this number that we have, which is 20 to base of 5, we said we are going to divide. What are we dividing with? We are dividing with the base that you are writing to, and you know the remainders. Okay. So I want us to do as what we did last time, as we're converting, writing as index form. You still remember that concept?
Yes.
Exactly. So we're going to do the same, but this time we are dividing by 5. We are not just dividing by any number. Specifically, we are dividing by 5. We are
5.
converting to base 5. So here you
Yes.
can note a column of what? Of remainders. So this is a column of remainders like that.
Okay.
Exactly. So if we divide 20 divided by 5, that is what?
4.
That is a 4, and we've got a remainder of what? A remainder of 0.
0.
Okay,
Okay.
still we are dividing by what? We are dividing by 5. So
By
this
5.
is now by 5. So it's a 4 divided by 5. You see that this one is impossible.
Yes.
So we are going to have a 0, then a remainder. The remainder now, whenever it is impossible, the remainder is the number that you are dividing with. You are the remainder is the number that we have with this case, which is what? Which is this 4. So it was 4 divided by 5. It's impossible. So we are saying 4 is the remainder. We couldn't reach this 5. Are we getting the sense there? Exactly. So here we shall have a number, which is what? Which is our 4. So like I was saying, these are the remainders. Now we can't divorce it. When if we divide by 5, it will be 0 remainders, 0, 0 remainders, 0, 0 remainders. So there's nothing that we shall have from these numbers.
Okay.
So you take your answer now from the what? From the bottom of remainders going up. So this is 4, 0. So our answer is going to be 4, 0 in place of what? In place of 5. So you take your numbers from the bottom going upwards. Are you getting the sense there? Exactly.
Yes. Yes.
Exactly. So that is how you convert. Okay, so this one, because of with just a basic number, let's just convert this same 20 to base of 2. Okay, so 20 to base 2. I think this one we can actually have a lot to do in this case. Okay, so this is our 20. We are converting to base of 2, so we're going to be dividing by 2, noting our remainders in this case. All right. So that's 20 divided by 2. which is what? Which is 10. Remainder
10.
what?
Mhm.
Remainder 0.
0.
Okay, we move on to 2 again. We divide by throughout. So it's 10 divided by
Mhm.
2, which is 5, and we've
Is
got the
5.
remainder of what? Remainder of 0 again.
0.
We do the
Mhm.
same by 2, that's 5 divided by 2. That is going to be 2, remainder what? Is the remainder of
1.
1. We do the same by 2 again. 2 divided by 2, that's a 1.
2.
Got a
1.
remainder of what?
2.
Okay, that one was
0.
a 1. Eh?
Yes. 0.
Okay, we do the same by 2. 1 divided by 2.
Oh, if you know 1.
Hello?
I'm saying we also divide even if it's 1.
Exactly. Yeah. Until we have got what? As you see, like what happened on 4
0.
here.
Yes.
Yeah, it was
Okay.
4
Okay.
divided by 5. Then we said it's a 0. Remainder the number that we had. Are you getting the sense here?
4. Yes.
So it's the same. So this is 1 divided by 2. So that's a 0. Remainder what?
0.
Remainder 1.
1.
Exactly. Now, what as long we reach a 0 here. So that is the last part. We can, well, even if we divide by 2, we divide by 2, that will be 0 remainder. So it's a repetition throughout. Are you seeing now if you reach a 0?
Yes.
Exactly. So
Yes.
now your answer is going to be taken from what? From the bottom of remainders going up. So these are your answers. So which means writing these numbers, we shall have what? That will be 1, 0. That will be 1. That's a 0.
0.
That's a 0 there. In base of what? Base of 2. We are converting to
2.
base 2. So now, if you leave the base now, what does it mean? You are simplifying here in this case. Then you leave the
Yeah.
base. What does it mean?
It means that it's base 10.
Exactly.
You've actually converted it to base 10.
You see now. So which means you are not supposed to leave the base. Once you leave the base, then you are telling the marker that now my answer is in base 10, and that would be wrong.
Okay. Okay.
Okay,
I
so
see that.
this is the conversion. So here we are not going to waste much time to say, let's divide, but let's use the base of 7. The idea is the same, whether it's 9, whether it's 3, whether it's 4, whatever base that you are given, this is the procedure that you're going to apply.
Okay.
All right, so now let's see the other way around now. We are going to convert from these bases that we have, base of 2, base of 5, back to what? To base of 10 now.
Base 10. Okay.
Oh, exactly. Okay, hello.
Hello. I'm
All
here.
right, sorry for, okay, so so now we are going to convert from any base to base 10, converting from any base to base of 10. Okay, so are we seeing what we have now?
Yes.
Any base,
Any
meaning to
base.
say we are talking of base 2, base 3, any. All right, so the idea is that you are going to express the given number, in powers of the given base, and simplify further. All right, so this is what you are going to do in this case. We have got a number which is, for example, in this case, convert 100,111 base of 2 to base 10. All right. This number that we have is in base of 2, and to convert to base 10. So we are saying in this case, we are going to express this number in the powers. This is the most important part, in powers of the given base. What are we referring to when we are saying in powers of the given base? Our base in this case is base of what? Base of 2.
2.
So we are going to express these numbers in base of 2. So we're going to start from the left side, from the right side going to the left, from this number that we have 1 going to the other side. So this will be 2 to to the exponent of 0. We start at 0, so it will be to the exponent of 0, 2 to the exponent of 1. We are using the base of what? Of 2. So we're going to raise from 0, increasing these numbers up to the last digit. So meaning to say this will be 2 to the exponent of what? 2, 2 to the exponent of 3, 2 to the exponent of 4, 2 to the exponent of 5. Each and every number is going to be affected by what? By 2.
2.
Okay, so this is what you do now. This was just an indication, but the normal procedure is that these numbers you're going to multiply. It's 1 times 2 to the exponent of 5. So you have to write it like this. 1 times 2 to the exponent of 5 like this. You move on to this 0 here. Okay, these are 0, 0. So you know that if you're multiplying by 0, that's a 0, but we are just going to write to show what was actually happening here. So this is 0 times 2 to the exponent of what? 2 to the power of 2 to the power of 4. The same thing on this 2 to the power of 3. This is plus 0 times 2 to the power of 3. So from each number to another, you add. From 1 to this, you add from, but these ones with exponent, you are multiplying the combination. You are multiplying the but the others you'll be adding. So you move on to this, it's 1 and 2 to the exponent of, so you add 1 times 2 to the exponent of 2. This is 2 to the exponent of 1. You multiply 1 times 2 to the exponent of 1. You move on to the exponent of 0 here, plus 1 times 2 to the exponent of 0. Are you getting the sense there?
Yes.
Exactly. So this is the idea that you're going to have. So once you have written, so I want you to understand this. I said you are supposed to express the given number in powers of the, and this is the most important, and simplify further. Why am I saying so? Because there is a question that is going to ask you to just express this number in powers of the given base. If you are asked to express the number in powers of the given base, this is the indication you leave your answer at this stage. That is what the question is asking you to do. Are you together? But if you are asked to convert to base 10, you have to simplify further and find the exact value, which is in base of what? Which is in base of 10. So what are we having now? We are going to simplify. So never make a mistake to multiply the numbers. You start by the exponent first, then you multiply to the number. So it's 2 to the exponent of 5. Then you multiply to 1. Okay? So never make it on this one, because it's 1, like you want to see what is happening, because here we are multiplying by 1. But if you are given a number like 3 times 2 to the exponent, then you will see truly that this thing does not work. Are you seeing this part? So yes, because we are only having a 1, so we won't see that idea there, but you see when you just change other numbers, then you say, this does not even work properly. Okay, so 2 to the power of 5 means we are multiplying 2 times 2 times 2 times 2 5 times,
which is 32.
Which is 32 exactly. So 32 times 1, that's 32. Are we getting? We raise to the exponent of 5, we got 32. We multiply to 1, that's 32. Are we together on this one? Okay, we move on to the same, but here we are multiplying by 0, so there's nothing that you're going to have here. Multiplying by 0, again, whatever that you get, you multiply to 0, there's nothing that you're going to have. All right, so you're going to move on to this one. 2 to the power of 2
is 4.
That is 4. Then 4 times 1
is 4.
Which is 4 exactly. 2 to the power of 1, which is 2. Then 2 times 1, which is 2. The same thing, 2 to the power of 0. That's 1. Then 1 times 1, which is what? Which is 1. Are you getting the sense there?
Yes.
All right, so you can add 32 plus 4, which is 36, plus 2, 38, plus 1, which is 39.
39.
Exactly, so this is 39 in base of 10. So like I was saying, a number written in base of 10 and a number which is just written like this is the same. So you can write 39 base, and also you can even write in words 39 base 10 if you want. Even in base 2, you can write maybe it's 1, 1, 1 base 2. You can even write in words base 2 like this. It's even allowed.
Okay.
Okay, so this one is just 39, or you can write it as what? As 39 base 10 or 39 base 10, like that. I don't know if this part is clear.
Yes, it's clear. Thank you.
Exactly. So this is direct because you are just converting, you're just raising to the powers of the given base. So it can be any number, any. So, we don't want to waste much time. I want us to just check how do they ask this question. So let me just share the screen to everything and see what we have. I hope we saw some of the sources that I sent in the group.
No, I didn't check.
No,
I'll check.
that day when I added you in the group.
Oh yes, oh that day. Yes. I
Yeah.
saw it. Thank
Oh,
you.
okay. So at least you can also utilize those books and question papers that can actually help. Oh, sorry, I don't know if you are seeing this book.
Yes. I
Oh,
see.
all right. So these are the typical questions that we have. So we do not want to waste much time. I just want you to see, because this part, the first part is direct. I want you to just see what's happening here. Convert the following. In this book, they are saying denary numbers. Denary meaning what? Base 10. Binary,
Okay.
binary base 2. So denary,
Okay.
that's base of what? Base of 10. Okay, but that part they will actually explain later on. Even if they ask like this in the question paper, they will specify that it's base of what? It's base of 10. Exactly. Then another important base, it's binary. They can say binary. Binary is base of what? Base of 2, and so forth. So these ones, they for now it's not that important, just to know because they've given like that. But what is important is to note how to convert base 10, base, and any base. Okay.
Yes.
So as you can see, the first part here, number 1, is converting the following denary, which is base 10, into the given base. That is this number to base 8. Are you seeing that in these numbers, they are not even given the base to say 230 base 10 is just 230?
Yes.
That is to show that your base 10 can be written anywhere. So I think the first part, all these numbers, they are clear. Also, number 2, convert the following numbers into denary, which is base 10. Are you seeing you are now going back to base of 10 on these ones?
Okay. Yes.
Exactly. So that is the last part that we had. So these ones, I think they are clear. Question 2. All these ones can just try. But if there's any part that is challenging, let me know. Okay.
Okay. I'll do.
All right. So now there is a. Okay. I want you to check number 3 there. This number 3. Are you seeing what is happening now? We are asked to convert the following numbers to the given base. 1, 2, 4 base 5, 2 base 2. Are you seeing what happened there? To say this number is in base of 5, you're asked to convert to base. Are you seeing we no longer have that conversion that we used to talk that we have been talking about, to say base 2 to base 10, base 10 to base 2. It's from another base to another base. Are you seeing base 10 is not involved there?
Yes.
Exact. So what do you think we can actually apply to this concept to convert 1, 2, 4, which is in base of 5, to base 2? What can we do now? Okay, we get back to what we are used to. We know that a number in base of 5 can be converted to a normal conversion, which we are used to, which is to base of what? Which is to base of 10. Because we said we can convert from any base to base 10.
Okay.
Also, we said we can convert from base 10 to what? To any base. So that means we are going to do a longer way now. We convert to base 10 that we are used to, then we convert to the base now that we are supposed to be used, which is base of what? Which is base of 2. Are we seeing how we are playing around that base 10 now?
Sorry, there was an incoming call.
Oh, okay. So I was saying here, since we are only used to base 10, so it means we are going to play around with base 10. We have to convert to base 10, then to the given base that we are supposed to be converted, because we can convert to base 10 and also we can play from that base 10 to another base. I don't know if we are together there.
Yes, we're together. Okay.
Exactly. So that means we are going to convert. Remember, 1, 2, 4. How do we convert to base 10? 1, 2, 4, base 5 to base 10. We said to convert to base 10, you are going to raise it to the powers of what? Of the given base, which is the base of what? Which is base of 5. So this is going to be 5 to the power of 0, 5 to the power of 1, 5 to the power of what? 5 to the power of 2. So that means we are converting to base 10. So this will be 1 times what? 1 times 5 to the power of 2. Okay, plus we move on to this one, 2 times 5 to the power of 1, plus we move on to 4, 4 times 5 to the power of 0. I don't know if we are together.
Yes, we're together.
Exactly. So here we're going to 5 squared, which is 25 times 1. That will be 25 plus 5 to the power of 1. That's 5 times 2, which is 10. Right, which is 10. Then 5 to the power of 0, that's 1. 1 times 4, which is 4.
4.
Right, then we can add, that's 25 plus 10, which is 35 plus 4, which is what, 39.
Yes.
Okay, so the 39 that we have obtained in this case is in base of what? Is in base of 10. We have managed to convert to base 10.
Yes.
So how are we going to convert this 39 from the base of 5 that we had? Now it's in base of 10. How are we going to convert now the 39, which is in base of 10, to what? To base of 2, because our answer is supposed to be in base of what? In base of 2.
2.
So we are back now to the conversion that we said from base 10 to any base. How do you convert? You have to divide by what? By the given base, noting all the remainders. So which means we are dividing by what? By 2 now. So we're going to divide by 2, noting our remainders down. So that is the idea there.
Okay.
All right. For that. Okay. So I don't know if it is clear.
Yes, it's clear.
All right. So let's divide 39, divide by 2. That's that will be what? 2 into 3, that is 1. Okay, let me just change the marker here. Okay. All right. So that's 3 divided by 1, which is what? By 2, sorry, which is 1, remainder 1. Then 19 divided by 2, that's into 18 is what? Into 18 is what? 9. Remainder?
9, remainder 1.
Or remainder 1. Okay, by 2 again, 19 divided by 2, that's into 18. Into 18 is what? 9 times, then there's a remainder of 1. Okay, by 2 again, 9 divided by 2.
4.
That will be a 4. Then we've got a remainder of 1. Okay. Take note, we are saying 9 divided by 2. That will be 4. Remainder 1. Then we divide by 2. So it's 4 divided by 2, which is what?
2.
Which is 2, and the remainder of what?
0.
The remainder of 0, exactly. Divide by 2 again. So it's 2 divided by 2, which is what? Which
1.
is 1. There is a remainder of what? The remainder of 0 again. By 2 again, 1 divided by 2. I see that 1 is smaller than 2.
Yes.
So we said for each, it's going to be a 0 exactly.
0.
Remainder what?
1.
The 1, exactly. That's good. So the 1 that is where is going to be our remainder there. Okay. So that is the idea. So therefore, our answer, as we said, is going to be taken from what? From the bottom upwards. So that will be our answer now in base of 2. It is going to be 1, 0, 0, 1, 1, 1. So that will be 1, 1, 1 in base of what? In base of 2. Are we getting the idea of what is happening there?
Yes, yes, I'm getting
So that is our 1, 2, 4 base 5 to base of what? To base of 2. So we meaning to say all these numbers that we have here, all these numbers, we can simply convert them to base of 10. After converting to base of 10, then we can convert to that base, whether it's base 8, it's base 5, it's base 7. We know that for us to convert to that base from base of 10, we have to divide by the what? By the base throughout,
the
noting what?
base,
Noting the remainders.
the remainders. Yes.
Exactly. So that is the major part, which is very, very important as long you are dealing with what? As long you are dealing with number bases. I don't know if there can be any questions from this part.
No,
All
no, I'll
right.
practice. If I
Oh,
face challenges again, I'll let you know.
exactly. All right. So there are some questions like this question, like for example, here we are where this can be actual paper one. Paper one, that's where you have these silly questions that just to I don't know what they will be thinking about these guys. But some of these questions you see that there's nothing that they're talking about. Just like which of the following numbers is even? An even number, we are referring to those numbers 2, 4, 6, exactly divisible by what? By 2.
True, okay.
So in order for you to see that this is an even number, there is only one way. We have to convert that word to base 10. That's where we
Yes.
can properly see that, okay, this is an even number. Because if you convert to base 10 and you see that your number is 7, then you can say, okay, 7 is not an even number. If you convert to base 10, then your answer is 20. Then you say, okay, so that means the number that I had before is what? It's an even number. Because if I convert it to base 10, it's giving me what? An even number.
An even number. Yes.
Exactly. So that's
So
what you simply. Hello?
you have to so you have to simplify all of this now. You have to
Yes,
change
because
this
here we are
number to all
exactly
of them.
because they're saying exactly because they're saying which of these numbers is even. So in order for us to see, we have to
Okay.
convert this to base 10. We check is it even or not. We convert this one, is it even or not? So under exam condition, they can just ask you a single question. Is 101 base 2 an even number? So that would be the question. But mostly
Okay.
we won't have that typical condition. Our paper one is either conversion, that is the major part that they want you to know to understand, converting from any base to base 10, and that one of base 10 to any base, and that part that we talked about on our last part. Then how to add or subtract. Those are the most important part in your syllabus.
Okay.
All right.
Okay.
So that is what you have. Just like this one, arrange the following numbers in order of size, starting with the smallest. There's no way we can arrange these numbers. If this is in base 8, this is in base 10, we can't even understand these numbers in this base. So the only way
Yes.
is to convert them to base 10. Then we can compare,
Okay.
because if I'm given 6 and 8, I can easily compare because they are in the same base. They're in base of 10. Okay, I'll say, okay, 6 is less than 8, or 8 is bigger than what? 6. Are you seeing what is happening now?
Yes, yes, yes.
So it's easier for us to have a comparison if numbers are in the what? In the base of 10, the one that we are used to.
Okay. Yes.
All right, so that is the idea that you're going to have. So these questions are just for revision purposes, just to
Okay.
understand more about the number basis, just and understanding more on on number basis there.
Okay.
All right, so what we want to do is to move on now to the addition and the subtraction of number bases. But we are going to start with addition, so I'm just going back to the screen. I don't know if you can see here.
Yes, I can see this too.
All right, so we are going to start with the part of addition. All right. So if you are adding number bases, I want you to, if you can understand this from the basic that we had when we are adding numbers. Remember, We used to have numbers such as these ones, 756 plus, let's just say 87. All right. These are numbers that we just used to say, okay, when you're adding, how do you add these numbers? We just add here 6 plus 7, that would be what? 13. Hello? Hello? I think it's network. Yeah.